Welcome back to the morning show. It is Wise Guy Wednesday, and today we're talking Willy Willies, also known as typhoons, also known as hurricanes. And with us is Matt Sellen to explain to us how the hurricane works. Thanks for coming in.
Well, you probably know more about this than I do, but I'm going to pretend I know everything because I looked at the U of I Atmosphere Sciences website, and it's awesome. They explain all this stuff, and
there was a lot of
smart.
Really good information on that.
So I want to talk about hurricanes because I was fascinated by how these things work, and there's tons of physics going on in these things.
Okay, then let's take weather and turn it to physics and make it fun.
Right.
All right.
Okay, so the first thing that happens, and you can correct me anytime I'm wrong here, by the way, okay, is you have a low-pressure system, like a bunch of thunderstorms. And that causes air to rush from the surrounding high-pressure area into the low-pressure area.
It kind of flows in.
It kind of flows in. And that's the same when you breathe. When you go like that, your lungs expand, and you have a lower pressure inside your lungs, and you know that the air all rushes in.
Right.
Okay. And then what happens is the air rushes in, and since it's all meeting in the middle, it starts to go upward. Now, it's very important that this air has moisture in it, because what happens next is as the air rises, it expands a little bit, and the moisture condenses out. And when moisture condenses out, you get a lot of heat released.
Right.
And we can show this here in a second. And when heat is released, it makes the air actually warmer, and it keeps rising, and this sort of system feeds on itself. So these things only form over the ocean where there's a lot of moist air, and the temperature has to be greater than 26.5 degrees, I understand.
Wow. And that would be 26 degrees Celsius.
That's right.
Okay.
And so we can show a couple of these physics principles right here. First of all, this notion of hot air rising in convection we can show right here. And so what I have over in this double sort of U-shaped pipe is I have a heater in the bottom of this one, which is causing hot air to rise here, and it's actually sucking cold air down this other pipe. And so I just have to light this piece of paper on fire so I can get a little bit of smoke. Okay, like that. And if I hold it, there we go, hold it there, you can see that that smoke is sucked down this one and is blown back up this one. So we have this convection that goes round and round. And where does all that heat come from in these storms?
This is a concept that took me a long time to get my head around in meteorology school, because this is really fascinating.
Here I have a cup of 200 proof alcohol. Okay, we're going to use this for this next demonstration. Okay. And the idea here is that, and if you can get a shot of this thermometer, this is sort of the opposite effect of when moisture condenses out, you get heat released. It's when moisture evaporates, you get heat absorbed.
It absorbs the heat.
That's much easier to show. And so right now this thermometer is in there inside this liquid, and it's at 72 degrees. If I just lift it out, so now this wet thermometer has the liquid evaporating from it, you'll see that the temperature plummets down to about 61 degrees very rapidly.
This is the same effect when you get out of the shower and you're wet.
Exactly.
And the water evaporates.
You get out of the pool, even when it's 100 degrees out in Phoenix, Arizona, you can get goosebumps when you get out of the pool. And so the opposite thing happens in a storm. You have the gas straw that's condensing, and you release all that heat, and then you get all that heat to heat the air, and you have this nice cycle.
Now we know how the storms form vertically.
Right.
When we come back, we're going to find out why they spin.
Why they spin. That's very fascinating, and you're going to spin yourself.
Okay, it's Matt Sellen, Wise Guy Wednesday on the morning show. We'll be right back.
All right. Right now?
That's right.